All right, let's do this example problem. Okay, so is that berkelium? Is that decaying into americium or something? I should know my elements. I might have just said something really funny. If you're laughing at me, that's fine. I don't really care. Okay, so basically we're gonna find out the left side is 2, 4, 7, 0, 7, 0, 3, 0, 0 atomic mass units, right? And then this is, let's add these guys up. So 243.061373. I always do it in threes because I'm such a spaz. Plus 4.002603. It's like a phone number. All right. The total right side mass is 247.063.976. Now just stop at this point, right? If this is not less mass than this, then the alpha decay is imaginary, okay? But at this point, we can subtract, right? Let's subtract, and we'll figure out the change in energy, right? So how much mass changed, right? So 247.070.300 minus the answer I just got. The mass defect is 0.006324. Some computer just got happy here, right? 0.006324 atomic mass units, right? And then multiply that by 931.5 because every atomic mass unit represents this many MeV. So times 931.5. Just in general, subtract masses and multiply by 931.5, and you're on the right track for this summative assessment. 5.89. We have 4 sig figs because of this, right? So 5891 MeV. There we go. And that's the energy of the decay. It's generally believed that the alpha particle carries that energy off as kinetic energy.